Enjoy. Enjoy this. A thin light cord is wound around in form. Around here, handle it with very professionally. You handle all of it. Light thin cord is wound around a uniform cylinder placed on a rough horizontal surface. Rough. When the free end of the cord is pulled by a constant force here, the cylinder rolls. Rolls means rolls without slipping. Denote radius of the cylinder R and obtain expression for work done by each of the forces on the cylinder. When the center of the cylinder shifts by a distance x. Captured the problem? Now draw the free body diagram first. Fast all of you. So they have told it is rolling without slipping. That means there will be omega here. And they have told take this as M and R. M they have not told, only R there. So therefore the friction will be like this. And this is the force that is acting. And obviously mg is acting down. So I'll show here. The mg is acting down. So mg is acting like this, and m is acting down. And this is the center. And this center will shift here. So this distance now is x. That's what they have told. So work done by each of the forces. The center has shifted by x.
Yes. Yes. Say what is it?
Normal. M. Center has shifted by x. So now what are the work done by different forces? So work done by mg. No, it will be 0. Work done by mg.
And even in that.
And work done by n. So both of them will be equal to 0. Obviously.
Yes, sir.
Now work done by friction.
Friction.
It is rolling without slipping.
Yes, sir.
Okay, so work done by friction. Okay, and work done by you have
Capital.
work done by capital F and work done by F. So work done by mg and m is 0. Work done by these two. Go by the first principles. It is rolling without slipping. So rolling without slipping, write this BC and write BC is equal to omega R. And therefore the distance moved by the center will be integration VC dt.
Sir, I have already given next thing.
They have given total displacement.
Sir, and
First is acceleration.
should find in terms of x, sir.
What is the work done by each of the forces?
And in terms of
What is the work done? Say what is the work done by this F and what is the work done by this F?
Capital F, 2fx.
Small f?
1 minute. Small f 0, sir.
Yes, everybody do it, please. He may be right or wrong.
Yes.
Work done by small f, work done by capital F.
Yes.
Work done by small f is 0. Work done by the fixture is 0 because it is rolling
Yes, sir.
without slipping. I told you in the first class only. This is
Yes, sir.
only force to grip. The point of application of force is not moving. That's all.
Yes,
Work
sir.
done by the static friction is 0. Okay.
Yes.
Now here you see the distance moved is Vc into x. Vc into dt.
Yes.
Then this will give you x. Okay. Then the velocity at this point. The velocity at this point, Vp will be equal to 2Vc.
Yes.
Yes, sir.
And therefore, the distance moved, the work done by this force F will not be x. It will be that is the displacement here. Delta P will be equal to 2Vc into dt.
Yes.
So therefore,
Yes,
the work
sir.
done by F will be F into 2x.
2x, yes, sir.
Yes.
Okay.
Sir, did it different?
You did it differently, huh?
Sir, like work done, sir, like tau bar dot d theta will you given us, sir. So there's if you consider because it's rolling, you can consider the lowest mode point with contact as the IC also. So at that point, sir, then that will be F into 2R, sir. The perpendicular distance will be 2R into F, sir. So that is tau bar, sir. What we have, sir. Then d theta, sir. The total thing will like the total is x, sir. Like when you integrate, you get it as x, sir. So x is in terms of something n into 2 pi r, sir. When you divide that by r, sir, we get the angular displacement in terms of
You calculated the angular
So,
displacement.
therefore,
You also got 2fx.
2x.
Yes, sir. Zero and
Tau bar for f is small f.
Great, wonderful. So this is also another way of this.
Yes.
Great. See, your face only has changed. Your outlook only has changed. That's all. So confidence will change everything. See, they say no, your face is the index of mind. You say your mind is confident, strong. You will look very nice, and you see so confidently you are telling every answer. Just 2 days ago, you were struggling with every answer. Okay, Karnataka Mari sutu badnikai idangitte. Ivattu aralidu hoo kade kaanutade. Excellent. Keep it up. See, Devant is answering so nicely. 2 days ago, he was cribbing and his face, was very ugly. Okay, so after the class, he was with me for half an hour. I counseled him, and I don't know. After that, he's changed. Okay, he's answering so confidently and so nicely without any mistake. Hats off. So therefore, you see, confidence is important. Just come and confide. Come and confide. See, his mother called me and told that he is very upset. He is feeling very bad the other day. Am I right? She called me and told me that he is feeling very bad. And then I told fine. What are the things? I collected the data from her mother. She told me everything. Okay. Then I spoke to his father. He told me everything. What all he does. Then I made a plan strategy. I just told him the truth. Okay, and that's it. He has changed. And even Arun, for that matter. Okay, more than Arun, his mother was very much worried about him because she was very confident that Arun will do very well. But for whatever reason, Arun was not doing well. So she gave me all the wonderful reasons why Arun was doing well. And that's it. So all of them, both of them are doing well, and I'm sure that all of you are doing well. If you are not doing well, you have issues, come and confide it. I will try and help you. Okay, and that's for your good. But your parents should also cooperate, you should cooperate, things will be fine. But don't make it too late, because most of the people will come late. ಎಲ್ಲ ಮುಗಿದೆಲ್ಲ ಚಿತ್ರಾನ್ನ ಆದ್ಮೇಲೆ ಏನಾದ್ರು ಮಾಡೋಣ ಏನು ಮಾಡಕ್ ಬರುತ್ತೆ. Okay, that's it. So don't make it too late. Okay, friends. These are all very, very simple. See now, the easiest thing in this world. That's it. Vg 0, Vn 0, Vfs is 0, Vt is equal to Vf, Va is equal to 2 Vc dt. Oh. Got it, friends?
Yes, sir. Yes, sir. Understood. Yes.
See, rigid body, everybody feels, oh, it's tough forgive and all. I think this is the easiest chapter.
Yes. Yes, sir. I'm feeling good.
Yeah, you will feel very good. You will feel very good. And if you become good in mechanics, next year optics, electricity is nothing. Okay, it is 50% difficult than this. And that's why you see, if you all cooperate, within 4 months, 5 months, I can complete the syllabus.
Second year.
You learn fast. See, you are learning so fast here. The same thing, I used to take, just 2 or 3 problems in mechanics in one day. Now see, so many problems and so much theory. Because you are observing. You are observing, I can go fast. If you are not observing, then I will go slow. I have to know, I have to pause and listen. But today Arun is quiet for whatever reasons. Okay, so this is using these symbols, IAR, which Deeman likes to use quite often. IAR. Okay, so same equation. So IP bar. IP is equal to fixed point. Only thing, the diagrams are good here, so I have just put it once again. That's all, the same things. So these are better diagrams. Let us slightly edit it. So central rotation, only I see. Okay, fine. Solve this more problem. So you solve this, very simple. So a rod of mass m, length L is pivoted to a fixed support at one of its head. It's rotating with constant angular velocity omega. Write expression for kinetic energy. Fast! Without pen and paper also, you should write this.
Yes.
ml squared by
Half into
ml
IP,
squared
ml squared by 2, ml squared by 3 into
omega squared, sir.
into omega squared.
Yes, sir.
Omega. Yes, sir.
Correct?
Yes. Yes, sir. Yes.
So it will become what? M
ml
L square omega square by 6.
Yes, sir. Yes.
Even Pratyush answered. Fantastic, man. Even Pratyush answered. Brilliant. Yes. ml square omega square by 6. Got it?
Yes, sir.
Yes, sir. Yes, sir.
Okay. Handle this. Uniform rigid body of mass m, round cross section, radius r, rolling on horizontal ground with angular velocity omega. Its radius direction about central axis is k. That expression for its kinetic energy is rolling without slipping. Already I have written, you have to rewrite it. When k is given, you write. They are given k. So I is equal to mk square.
Yes, sir. Sir, what is the second in the subquestion?
First sub question, write expression for kinetic energy. Also express kinetic energy as sum of kinetic energy due to translation of mass and kinetic energy due to simultaneous centroidal rotation.
Yes.
Only one thing.
Both are same.
Both are same only. So this is what they have. So the total kinetic energy will be half m bc square plus half I omega square.
Yes.
But they are not given m, they have only given k. They have only given k. M is given. Sorry, mass m is given.
And radius
R is given.
R
M
is
is given.
given.
Yeah, yes, yes, R. So R is also given. So m is given, R is given, then omega is given, and k is given. Very chiller, you can write.
Yes.
Why radius?
Buddhi do. Okay, I think all of you can write this now.
Yes, sir.
Wrote also, good.
Yes, sir. Also.
These are all NEET questions.
Yes.
These are all NEET questions.
Sir,
Today-
other two questions.
NEET.
Sir, other two questions.
Yes.
Huh?
Other two questions.
They were also NEET.
Yes, sir.
We didn't. Which you solved.
B and C.
ಈಗ ತೋರ್ಸಾಕೋದಿರಲ್ಲ ಎಲ್ಲಿದೆ ನೀ ಅದೇ ಹೇಳ್ತೀನಿ ಎಲ್ಲ ಅದಿ ಇವತ್ತ ಈಗ ಅದ ಕ್ವಶನ್ ಸಾಲ್ವ್ ಮಾಡಿದ್ದೀನಿ ಅದ್ರ ಆನ್ಸರ್ ತೋರ್ಸಾಕತ್ತೀನಿ
Nam sir.
Yes, yes.
ನಿಮ್ಗೆ ಓಕೆ
Yes. Yes, sir. Yes, sir.
ಸೇಮ್ ಎಕ್ಸ್ಪ್ರೆಷನ್ you get it for B also same.
Yes.
Only thing is here we have used the IP.
Yes, sir. I see.
Okay, and here it is written separately.
Yes.
Okay, friends, others?
Yes, sir.
Yes, sir.
Good.
Yes.
Sir, in that previous question,
Huh?
you have to use IC or IPs. Why do you use IPs?
Andre, see, they have used, see this is rolling now, so they have calculated the kinetic energy about this point. The kinetic energy by taking this as the axis of rotation. So they have to use IP there.
Okay, we can write it with respect to IC also.
Ah, man, that is what first thing they took this and wrote, and second time they wrote it separating it as translation and rotation.
Yes, sir.
Second time they wrote like this. Okay.
Yes.
A thin meter scale is kept vertical by placing its one end on the floor, keeping the end in contact stationary. It is allowed to fall. Calculate the velocity of the upper end when it hits the floor. Scale ಹಿಂಗೆ ಇಟ್ಟಾರ
sir.
ಕೈ ಬಿಟ್ಟು ಕೂಡಲೇ ಟಪ್ ಹಾಕಂತ ಹಿಂಗಿರುತ್ತೆ. Okay, so calculate the velocity of the upper end when it hits the floor. Just before it hitting the floor, what is the velocity? ಹಿಂಗೆ ಇಟ್ಟಿದ್ರೆ ಸ್ಕೇಲ್ ಅವಾಗ ಬಿತ್ತ. ಮೀಟರ್ ಸ್ಕೇಲ್ ಅಂದ್ರೆ ಗೊತ್ತಲ್ಲ? ಹಾ.
Yes.
So this was the meter scale. Okay, now it will fall flat. So this length is 1 meter. So it will fall. So when it is just about to fall, what is its speed? Somebody can tell the strategy other than Srijan, Om, Dimant, Arun, Kabadi, all these 4 people who keep telling. Other than that, somebody can answer. When it is standing upright, what is the energy of this? Only potential energy.
Yes, sir. Yes.
Okay.
Yes.
mg L by 2. L by 2 is half meter.
Yes, sir.
Okay. And when it is about to fall, touch the ground, entire energy is kinetic energy.
Yes, sir.
Yes.
Okay. So you should take this point as O. Okay. Half I about point P into omega square.
Yes.
Okay. And IP is what? IP is M L square by 3.
3. Yes.
Okay. Into omega square. Omega, and here what is this omega? What is omega? We take it as omega here. And what is it now? You'll have to convert it into velocity.
Square by x.
Yes.
V is equal to omega r.
So omega is equal to v.
Sir,
Omega is equal to V by r.
Yeah, we can use that v is equal to omega.
In half I omega square, instead of omega square you write V by r whole square. Okay, and r here is L.
Yes, sir.
yes.
Sir, add an element.
By r is equal to L by 2.
You should take center of mass.
Why?
I know, sir. Okay, sir. I have written for something. Sorry.
Because it is falling like this, no? The velocity of the tip
Yes,
is
yes.
okay, so L
Yes,
square
yes.
L square will go. So this becomes M by 6 into V square. L square will go.
Say my only half IP omega square. Why not half omega square L square?
Huh?
Half MB square also we should take this.
Correct, sir. It will have velocity. Center of
Yes.
mass will have velocity.
So
I
the stationary,
take this, that topmost point, so its potential energy I have taken LHS. RHS you should take its kinetic energy, sir. So your total energy is considered.
Perfect kinetic. Maybe transmission kinetic.
We are thinking about that point O no sir.
So half MB square plus half I omega square is equal to mgh.
It will be the ICU or the
Yes, sir.
that point O.
No, we are taking
So
it
this
about,
will-
we are taking about this point. This whole thing has only rotated.
Rotated. Yes. About the centroidal the same.
About this point it has rotated only.
Yes, sir.
yes,
So it will be
Then why will you take this there?
So center of mass will have some velocity. So that means the rod will also have some kinetic energy.
ಇಲ್ಲ
And this is vertical.
ಇಲ್ಲ ಇಲ್ಲಿ ನೋಡಿ ಹಿಂಗಿರ್ತದ ಇದು ಹಿಂಗಿತ್ತ
Yes.
ಹಿಂಗಿತ್ತ ಇದು ಹಿಂಗ್ ಬಿತ್ತ so its entire energy is no this has only rotated about this point.
About that point. Yes.
It has rotated about this point. It has not rotated about this.
Sir.
Hello, it has not rotated about the center of mass.
Yes.
Yes.
See, if it had rotated about the center of mass and the center of mass is also shifted here, then it is a question. Understood now?
Yes, sir.
If it has rotated like this and fallen, but it is not like this, only fallen. So only this is right. So here, this 2, this 3, and this m will go. So you get here, v square is equal to
So it's when mg is by mg 1 by 2. It should just mg. LHS LHS.
hello m6 ಅಲ್ಲ ಇದು.
Others only man. First equation mg into 1, not 1 by 2.
L by 2.
L by 2 sorry 1 by 2 ಬರೆಯುತ್ತಿದೆ L by 2 sorry. Okay, take it L by 2. L is equal to 1 by 2.
Sir, only H by L by 2.
Hey, potential energy is what? mg L by 2. ಅದ ಹೇಳಾಗುತ್ತೆ ಇವತ್ತು ನಿಮ್ಮ ತಲೆ ಸರಿ ಇಲ್ಲ ಎಲ್ಲ ಇದೆ ನಿಮ್ಮ ಮೈಂಡ್. See, this is the problem with you. One day you are very alert, one day you are not alert. See, now I am telling all of you, there are so many things that are happening around each one of us. So many problems are around us. Okay, see, human life is like that. Okay, our human life is like this. See, we are there. Each one of us are different. So around us, there are so many obstacles. Obstacles means, you see, now in your home, this is the condition. In somebody's home, somebody is the condition. Or your hormones are different. So for you now, you get tired fast for the same amount of food. For somebody else, for the same amount of food, they don't get tired. So many things are there. So all these are constraints. So in spite of those constraints, you should find the path. Okay, righteous path. And try to reach your goal for the day. Each day you should define. And what is your goal for the day? Understand? So all these are constraints. Something has happened, somebody told something to you, or you told something to somebody, and you are feeling bad. So please keep all those things away. Okay? See, There are a lot of time for us to think about all that. Supposing we have done something wrong, all that we have to do is, yes, I have made a mistake. Go see if you can atone that mistake, if you can correct that mistake. Or if you have harmed somebody, go and tell sorry to that person. That's all. You should not create a racket within yourself. Oh, I did that mistake. I think he is feeling very bad. What I did here, he is feeling very bad here. What I did. Go on creeping, no use. Go to that person and tell. That's it. Understand? So please, all of you, be alert and nice. Okay. I think I am done.
Yes.
Hello.
Root
Yes,
is
sir.
Right?
Sir, L will be equal to 1 also.
L will be equal to
Yes,
1.
yes.
L will be
Yes.
equal to 1. That's it. Correct. See, we also
root
got
3
it.
is
Yes, sir.
Okay. Your father is coming to pick you? Your father is also going to come and pick you. Okay. I had to show you one video today. I'll show you tomorrow. No issues. So tomorrow all of you should become Sherlock Holmes and come.
Okay.
Okay? I'll give you one situation. You have to investigate and tell me. Okay? Sherlock Holmes, detective. Sherlock Holmes is a detective. Pa.
Sir,